All of these problems have to do with the normal distribution curve. This is what we call the bell curve. Okay, this is a normal curve. All this means is that most of the data, right, this vertical line here is your y-axis. This is the frequency. How many people scored here would be like that. How many people scored whatever this score was, you would go up to the line, and wherever this line hits that line, that's the number, okay? That's how that works. So a normal distribution curve should be symmetrical. It should only have one hump. It could look like this. It could look like this, right? The hump is getting taller. It could even look like this, right, with a real high hump. It doesn't matter. These are all normal. Again, as long as it's symmetrical and as long as there's only one hump. And this is your Z-score formula. In other words, this is how you standardize all of your test scores. If somebody got a 62 and the mean was 70, so 62 minus 70 would be -8, and let's pretend the standard deviation was 4. So it would be -8 divided by 4 is -2. So that means that person that scored a 62 was 2 standard deviations below the mean. That's what the negative part means. But let's go ahead and answer these questions. The mu here is the population mean. That's what the Greek letter means, population mean. This is the sigma. That is the population standard deviation. And the Z-score is literally how many standard deviations this guy is, this individual piece of data is away from the mean. I'll say that again. A Z-score is how many standard deviations away an individual piece of data is from the data set's mean. So question 5, what's the area under a normal curve with a Z-score of -1.13? Hold on. We'll go back to here. So this middle line right here, this is the mean. The Z-score, the mean Z-score is 0 of a normal data set. So this number right here would be 0. So it would be +1, +2, +3. This again would be 0, -1, -2, -3. What you got to know is that the area under the entire curve is 1 or 100%. So if we're looking at a Z-score of -1.13, it would be -1 right around here. Bam. So what you do is you draw a straight line from here to here, and this little chunk of cheese right here, that's the area they're looking for. So it's going to be real small percent, but we're going to do this in Excel. So here's the formula right here. So for any Z-score, it will give you the area under the curve for any Z-score by using this formula, equal norms dist. There's an S in there, be careful. So what you do is you go to Excel, pick a cell, any cell, okay? You can go to that function bar, and it opens up all the functions. Make sure that you are in statistical, beep, and then you're going to scroll down to norms dist. Make sure it's got the S in between there, norm S dist. And so it asks you what's the Z-score. For this problem, it's -1.13. And cumulative, I always just type in true. And that is the area right there. Let me make that big enough for you. So again, that is the area of that little chunk of cheese where the Z-score is -1.13. So now let's do the next one, 2.27. Again, let's look at the bell curve. So 2.27, so there's 0, 1, 2, 2.27 is going to be here. And remember, the area is everything to the left of that, so it's going to be real close to 100%. Say that again. So at 2.27, there's 1, 2, 2.27. It's going to be somewhere right there. That's where the Z-score is. And the area associated with that Z-score is going to be everything to the left of it. So that's going to be pretty close to 100%. But let's pull out our old handy dandy here. And we're going to do the same thing. We can use the same formula, equals norm S dist. I can simply go up in here and change my -1.13 to 2.27. Enter. Bam. So that's the area for that one. Let's do the next one. What's the Z-score? What's the area under the curve for a z-score 0? That is a trick question because the mean of a set of data, which is a z-score of 0, cuts it directly in half. But if you don't believe me, let's go back to our spreadsheet here. And again, it's equals norm s dist. And we'll just make that z value of 0. It should come out to be 0.5. Perfect. Okay. All right. Up to this point, we were doing less than whatever the z-score is because that's what the value is of the area under the curve. But now we have a greater than. So the greater than problem is a little bit different. But again, you find the area under the probability curve for a z-score of negative 1.58. And if it's greater than, all you do is subtract it from 1. Let me go ahead and do that for you real quick. So this has the formula already in it, and we want, what is it, negative 1.58? Negative 1.58. That's going to give us everything to the left of the curve, but we want to subtract that from 1. So to do that in Excel, simply go put your cursor between the equal signs and the letter N and put 1 minus. Minus is just your hyphen bar, and that's the area of 0.9429. Let me try to give you a visual on that. Hold on. I kind of screwed up on the numbers here. It should be negative 1.58, but this is close enough. So if you had a z-score of negative 1.56, you'd get a p-value of that little chunk of cheese there to be 0.0594. But now if this was greater than that number, right, if you're looking for the probability of a z-score, the area under the curve of a z-score that's greater than negative 0.156, you simply take the value that's less than and you subtract it from 1, and that gives you the other side, and that would be 0.946. Less than, those are all the data that comes out from Excel or that's going to be on the sheet. And if it's greater than, you simply subtract from 1, whatever that value is. And this one is a less than, negative 1.58. That is too easy to behold. So we just go back up here and erase the 1 minus part. All right. Equals norm s dist parentheses negative 1.58 equal true, and that's the answer to that one. This last one is the in-betweener. So it's practically most of the data set. Let me see if I can't pull this up and give you a quick snapshot of it. So it's going to be from negative 2, which is right here, all the way up to positive 2, which was right here. It's practically 100% of the graph. Remember, it's between these two. But this is how you do this. You go ahead and put in norm dist of, you always do the positive one first, the biggest one first. So we're going to find the area under the curve with a z-score of 2. And then we're going to highlight everything except for the equal sign. We're going to copy it. We're going to go to the outside of the parentheses. We're going to hit minus. Again, that's the hyphen bar. And then paste it back in there, Control V. And this time we're going to subtract out negative 2. And we're going to hit enter. So there's the area between the two right there. And that's all she wrote, said to goat. So that's it for this one. MGZ out.